Homework question was on problem number 33 from last night. If a polygon has three sides, then it is a triangle. If a polygon is a triangle, then it has three sides. We want to write this in a biconditional statement. So what we could say is a polygon has three sides if and only if it is a triangle. So a polygon has three sides if and only if it is a triangle. Or we could say a polygon is a triangle if and only if triangle if and only if it has three sides. We can write it in either order. Questions on this here? Any other questions on the homework before we get started? Yes. 38. See what 38 says. 37, 38. The conditional statement says, if it is raining, then I will bring an umbrella. Its converse says, if it is not raining, then I will not bring an umbrella. Well, the conditional statement and the converse is what? Flip, because the converse is the flip of the conditional statement. So if the conditional statement says, if it is raining, then I will bring an umbrella, the converse should say, if I bring an umbrella, then it is raining. Would be the actual converse. What did they actually write? They wrote the inverse, because the inverse is the negation of the original statement. So they wrote the inverse instead of the converse.
It smells like toothpaste. I really thought you liked it.
So here, for this problem, one, they wrote the inverse instead of the converse, because we need to explain what the error that occurred. And the correction is that it should be, if I bring an umbrella, then it is raining, is what the correction should be. Questions on this here? Are we good?
Yes.
Okay. 34? What does 34 say? Quadrilateral. If a polygon is a quadrilateral, then it has four sides. So we could say a polygon is a quadrilateral, what? If and only if it has four sides. Any other questions on the homework before we start today's lesson? Okay. Let's put the Chromebooks away. You don't have to close them, but let's just put them away for now. What we're looking at today is inductive reasoning. What we're going to look at tomorrow is deductive reasoning. So let's look at inductive for today. We'll look at deductive tomorrow. Inductive reasoning. A conjecture is an unproven statement that is based on observations. You use inductive reasoning when you find a pattern in specific cases and then write a general or a conjecture for the general case. So what are we looking at? Inductive is based off of what? A pattern. And we make a conjecture about the pattern. So once we see a pattern occurring, we are using inductive reasoning to kind of continue that pattern on, what we expect to occur. So we're going to be using that throughout the lesson today. So if we look at this here, describe how to sketch the fourth one in the pattern and sketch it. Well, our first one, we have half the figure shaded. The next one we have a fourth, because this is half. Then we have a fourth, and then we have a... So what do we think the next one would be? An eighth, yes? So, circle, 1, 2, 3, 4.
Wait, are these supposed to be shaded on ours?
Yep, the printer just didn't print the shaded region. So the next one in the sequence would be an eighth. And that's it. Questions on this here? So what is it doing? We're really cutting the previous one in to another section into halves, but that's it. I just want that. Not too much now. Any questions on this here? Let's look at the next one. We are going to have another star. But what's changing from one star to the next? It's losing one, because in the first one we have one that's not shaded. And then we have 2. And then we have 3. And so in the last one, we're going to have how many that aren't shaded? 4. So we're removing one of the shaded regions each time. What would happen if we continue this pattern one more time? Yep. So it would just be the inside that's shaded. Any question on number 2 before we look at number 3? So let's look at number 3. So we start out with 1 circle, and then we end up with 3, and then we end up with 6. So what would we do to get to the next one? We'd add another row, and this one would have 4 in it, which would give us a grand total of 10. Because if we wanted to do the next one in the pattern, we would add another row, which would have how many? 5, because the last row had 4, so the next row would have 5. Because each row is increasing by an increment of 1. Questions on this here? We're good with this here? Describe and sketch the fifth in the figure. So figure 1, we have how many squares? Figure 2, how many do we have? 3. Because we start off with 1, then we have 1, 2, 3. Figure 3, we have how many? 5. Figure 4, we have. So how many should we have in figure 5? 9, because we went 1, 3, 5, 7. We're increasing by 1. Because each time 3 and 2, so 3 and 2, we added 1. In the previous one, we had 3, and the one before it. So each time we're adding a square onto each side. So 5, 5, and then I should have 1. Because here it had 1, 2, 3, 4. So we should add 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 2, 3, 4, 5. But we do have a grand total of 9. Any questions on this here? Do we feel good with this here so far? Yes? Okay. So now we're going to test and make and testing conjectures with numbers. Because looking at the figures and seeing how they work is not that bad. So let's look at some numbers. Numbers such as 3, 4, and 5 are called consecutive integers. Make and test a conjecture about the sum of any 3 consecutive integers. So we do 3 plus 4 plus 5. So we just need to add these 3 together. 3 plus 4 is? 5 is 12. So give me another 3 consecutive integers. 2, 3, 4. 2 plus 3 plus 9. Okay. Has anybody seen a pattern emerging yet?
3, 4, 5, and then 2, 3, 4, 8.
So they are going in order, but there's something how these 3 work, or some property with these that give us 9. Well, 3 times 3 is? Let's see here. Let's do 68, 69, and 7. I just picked another set of 3. 68 plus 69. 8.
Oh, 130.
7 plus 70 is 207. Now, what we're saying is if I take 69, 3 times 9 is 7, carry the 2. 3 times 6 is 18, plus 2 is 20, which gives us 207. So what we're saying is that the middle number times 3 will give us the sum of these 3 numbers. So let's try another one. Let's say negative 4 plus negative 3 plus negative 2. Well, negative 4 plus negative 3 is negative 7. Plus 2 is negative. What is negative 3 times 3? So it works out, after looking at this here, the sum of any 3 consecutive integers is 3 times the middle number. 3 times the middle number. Now, with a lot of these here, because you will have some of these on the assignment, write out a bunch of examples that fit it, that fit the number set, and see, does a pattern emerge? Because some, it might take you 1 or 2. Others, it might take you more to be able to see the pattern. Bless you. Any questions on this here? Are you ready for the next one? Make and test a conjecture about the product of a negative integer and a positive integer. Someone give me a negative integer. Or -5 and -3. We'll use both of them. Give me a positive integer. 7, and then we can use 6. Give me another negative. -1. What's -5 times 4?
12. Or 20.
And it would be -3 times 7. -1 times 6. So do y'all see a pattern when we multiply a negative integer and a positive integer? They come out to be negative, yes. The product of a negative integer and a positive integer is always a negative integer. So the product of a negative integer and a positive integer is always a negative integer, or always a negative. Because that's one of the things we learned in Algebra 1, wasn't it? Negative times a positive is always a negative. Questions on this here? Yeah, you're good. We good to go on to the next one? Make and test a conjecture about the sign of the the sign of the product of any 3 negative integers. So what's a negative integer we can try? -2, another one. And lastly, -8. Well, -2 times -4 would be +8. 8 times -8 is -64. Do we see a pattern with a negative, and a negative? Because the negative times a negative is a positive. A positive times a negative is a. So the product of any 3 negative integers is always negative. The product of any 3 negative integers is always negative. Yes. Questions on this here? We good with this here? All right, the last one we'll look at here is the make and test a conjecture about the sum of any 5 consecutive integers. One plus 2 plus 3 plus 4 plus 5. 3, 6, 10, 15. Yes. What's another number we can start at? As I throw this. 5, 6, 7, 8, 9, 22, 23, 24, 25, 26. 35. And this should be 120.
He just did that in his head. He even needed.
Well, because the sum of any 5 consecutive integers is what? Which is? So the sum of any 5 consecutive integers, e.g., ERS, e.g., is not 7, 5 times the middle number. So we take whatever the middle number is, multiplied by 5, and we get the sum of those 5 numbers. Now this works better with odd sets of numbers, so 5, 7, it would work the same, 9 would work the same. Even kind of works the same, but we don't actually have a middle number. We would actually have to find it, and it would work similar. Questions on this here? All right, the last thing we're going to look at is a counter example. Now, to show it that a conjecture is true, you must show that it is true for all cases. So for every single possible case, we have to show it's true. However, to show that a statement is false, we only need one. If we can show that it's false, one counterexample, then the whole thing is false. If I can show one counterexample, then the whole statement's false. But if it's true, I have to show every single possible case. Yes. Now, a lot of the times it is hard to show that every single one is true. So what they will use is a counterexample. So like on the last one, the sum of any 5 consecutive numbers is 5 times the middle term, yes? Well, we could say that the sum of any 5 consecutive numbers is not equal to the middle number times 5. I can show one example where that is false, because we had 3, didn't we? So that means that's false. So the other statement has to be true. Because that's where negations come into play. Because if we can negate the statement and show that it's false, the original statement must be. So let's look at this first conjecture. Then we want to show a counterexample for it not working. The first thing is that the sum of 2 numbers is always more than the greater number. So I could say 7 plus 9. 7 plus 9 is 16 greater than the bigger number of 9? Okay, so that wouldn't be a counterexample because it actually holds true. What would be a counterexample? Okay, 6 plus 6 would be 12 is greater than 6. Okay. So give me an example. What's negative 2 plus 4? Is 2 greater than 4? Yeah, but there's a counterexample. Because the negative made it smaller. What's another counterexample we could use? Let's see. What is 4 plus 0? Is 4 greater than 4? Yep. It's always more than. If it said greater than or equal to, then that would work. Then we would just stick with the negatives. Questions on this here? Well, how many did we need? One, so either one of those would work. A student makes a conjecture about absolute values. Find a conjecture counterexample to disprove the student's conjecture. The absolute value of the sum of two numbers is equal to the sum of the two numbers. So what they're saying here is the absolute value of A plus B is equal to A plus B. That the absolute value of the sum of two numbers is equal to the sum of those two numbers. So what we can say is that the absolute value of 2 plus 3 is equal to 2 plus 3. Well, the absolute value, or well, 2 plus 3 is 5. Now on the left-hand side, we have the absolute value of 5, which is 5. 5 is equal to 5, yes? So we want to find a counterexample that disproves this statement. Absolute values. So absolute value. So what are our two numbers, Lily? So just negative 8 and 10? Negative 8 plus 10. Negative 8 plus 10. Well, negative 8 plus 10 is 2. Negative 8 plus 10 is? The absolute value of 2 is? Yes. So negative 4 plus 3 is equal to negative 4 plus 3. So inside the absolute value bars, negative 4 plus 3 is? Negative 1. Negative 4 plus 3 is? And 1 is not equal to negative 1. So Lily, yours would have worked if the 10 was negative and the 8 was positive. Because once we get a negative inside the absolute values, when it comes out of the absolute values, it becomes positive. On the other side, since we don't have the absolute values to adjust for that negative, it stays negative. Questions on this here? X squared is always greater than the value of x. So we're saying that x squared is greater than x. So we could say like 2, that x is 2. Well, 2 squared would be 4. And 4 would be greater than 2, yes? Exactly. Now, if we try negative 2, what is negative 2 squared? Because a negative 2 times negative 2, the negative times the negative is a 2 times 2 is 4. Now, whenever you type this into the calculator, you need to make sure you do have the parentheses around the negative 2. Because if you just type in negative 2 squared without the parentheses, it will tell you that it is negative 4. Because what the calculator is actually doing is negative times 2 times 2. It does not see the negative and 2 connected. We need the parentheses around the negative 2 to show that we're taking negative 2 squared, not just 2 squared. Well, this here is true, yes? Okay. What would be another number that would work? Four squared is? 16 is greater than 4, yes? Well, negatives don't work. Negative whole numbers don't work. Positive whole numbers don't work. What number is not positive or negative? What is 0 squared? Is 0 greater than 0? there's an example. What is 1/2 squared? It's not 1. So we would square the top and bottom. 1 squared is? 2 squared is? Is 1/4 greater than 1/2? Because it does work out that anytime we square a fraction or a decimal, it gets smaller. So decimals or 0 would disprove this here. Any questions on this here? The sum of two numbers is always greater than their difference. This is the last one we'll look at. So what this is telling us is that A plus B is always going to be greater than A minus B. So I could say 3 plus 2 is greater than 3 minus 2. Well, 3 plus 2 is, and 3 minus 2 is. Okay, so that does work. What? 0 plus 0 is? 0 minus 0 is? Well, we could also use, say, 3 and negative 2. Well, 3 minus 2 is? Negative and a negative make a? So either one of those would work. So on the homework, make sure to be reading the number types because they might specify positive integers, non-negative integers. Any questions on this here? That's it. So your homework is on page 74, 3 through 5, 7, 9, 10, 12 through 15. And that is it for today. Tomorrow we will be talking about deductive reasoning. Yes?